Euclid's Elements, Book 3, Proposition 6. If two circles touch one another, they will not have the same center. So if we have two circles and they touch interiorly like this, so let's have circle A, B, C, and circle A, D, E. I say they will not have the same center. But if not, this is again a proof by contradiction, then let's assume that they do. Let's assume they do share a center. So let it be F. So we can connect this point here. We can take another point at random like this. So let's have our center be F, and let's have this line extended. We'll have this be E right here, and we'll have this be C right here. Just keep things nice and clear. So we know from book 1, definition 15, that the radii of a circle are equal. So if we look at this small circle, circle ABC, we know this is equal to this because they're both radii of the same circle. But, so we know that AF is equal to FC. But also from definition 15, if we look at this big circle, we know that this is the radius and this is the radius. Therefore, AF equals FE. We'll mark that in blue. So AF equals FE. Well, what we can see is these two things are equal to the same thing, therefore they're equal to each other. Therefore, FC equals FE. What's the problem with that? Well, FC is clearly a part of FE. So this lesser part can't be simultaneously lesser and equal to FE. So we're saying that this lesser is equal to the greater. The lesser equal to the greater, which of course is impossible. Violation of common notion 5 that says the whole is always greater than the part, so the part can't be equal to the whole. Therefore, this must be rejected as absurd. Therefore, the assumption that gave rise to this must be rejected. Therefore, they cannot share a center. And that's what we were proving. That if two lines touch each other interiorly, they cannot share the same center. Since we've proved that, we conclude QED.